Welcome back to the Rule Your Pool podcast. This is episode 114, and in this episode, we're going to talk about a pretty complex subject, so I want you to buckle up. This is a little more deep on chemistry, and in order to discuss this topic, I wanted a real expert on here, and that's why we have Terry Arko. Welcome back to the show, Terry.
Thanks, Eric. Glad to be here, and yeah, this is a good topic to talk about.
What are we talking about today, Terry?
Well, we're talking about bromine chemistry. Mm-hmm. I've taught water chemistry for a long time, and bromine's kind of that second primary sanitizer that is like chlorine, but not like chlorine. So it is good to talk about and teach on.
Yeah, let's do it. So this is episode 114, Understanding Bromine. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Now, to be honest with you, Terry, this is kind of a painful thing for me to talk about because when I was a collegiate swimmer, the first 3 years of my swimming, it was a bromine pool. And I remember it. I remember that distinct smell, and I liked it. It has nostalgia for me. I remember what those years were, and that was clean water. I never had any breathing problems. It wasn't a problem. Now, granted, the water did look kind of green, and we'll discuss that in this episode, but the moment they changed to Cal Hypo, the water got beautifully blue, but I started getting sick. And in fact, the entire reason I'm in this industry is because I developed lung damage from swimming indoors. And it started there. It started when that pool switched from bromine to chlorine. So I've always had a positive opinion of bromine. And then I do this research and I realize, maybe it is not the golden goose like I thought it was. So what's your opinion on bromine?
Well, I'll tell you, experiential wise.
Hold on. That's not a word. Experientially?
It is. I just made it.
Oh, you just made it. Okay. We're going to go with
based on experience or experiential. I'm a West Coast guy. So as far as pools, we didn't see a lot of bromine use. I'm going to assume that the pool that you swam in that you liked was an indoor pool, possibly.
Yes, it
was. Yes. So we'll talk about why that is as we go along in the podcast, I'm sure. You don't see a lot of use of bromine in outdoor pools.
And shouldn't.
Right, and shouldn't for many reasons. And so we didn't have a lot of indoor pools on the West Coast where I was. Mostly where my experience was early on was bromine in hot tubs. And right. I think it's interesting that you mentioned the differences in smells and odors between the bromine and how the bromine has that clean nostalgia for you, whereas the Cal Hypo wasn't. And it's really interesting because I'm huge into origins and word origins, like experiential. Bromine comes from bromos, which is the Greek, which actually defines into stench.
Oh, it does smell. There is a distinct smell to bromine, yes.
And apparently, if you do your research, the bromine, which is in a liquid form, it's not a gas like chlorine elementally, it's a liquid. And in that liquid form, it does have what they describe as a very sharp odor.
Yeah, well, we don't smell that in the pool, of course. We smell the pool version of it. So let me just do a quick run through of why we're even talking about this. So pools need a residual sanitizer. Everybody talks about, I want a chlorine-free pool. Well, this is an alternative to chlorine. It is a halogen gas. Elementally, it is right under chlorine on the periodic table of elements. Above chlorine would be fluorine, and I learned researching this that the reason we don't use fluorine in swimming pools is it actually attacks water itself, which is crazy.
It can oxidize water.
Right, exactly.
And which we don't want.
Right, so we use things like sodium fluoride in our toothpaste, which helps our teeth get clean and stuff. And I want you to think like sodium fluoride, sodium chloride, sodium bromide, sodium iodide. Terry, you put it in plain English for me because I didn't even catch what these things are. And you just said elemental halogens create what?
Salt, or they're salt formers.
That's exactly right. And I had no idea. It never occurred to me that the common algicide sodium bromide is literally just bromine salt.
Well, the interesting thing about that is if you look at fluorine, you look at chlorine, you look at bromine, you look at iodine, those are all really toxic materials, highly toxic materials. But then you combine them to sodium, and in the example of chlorine, chlorine is a very toxic material, but yet you combine it to sodium and you have table salt.
Right. And it's not toxic at all.
Not toxic at all. And then the same with bromine. You have bromine, which bromine's highly toxic, but now you combine that with sodium and it becomes more of an inert material. So
right.
I think that's interesting.
I agree with you. And we need a residual sanitizer in swimming pools because you need something in every corner of the pool.
Correct.
You have to have a first line of defense. You can't just rely on a UV or an ozone system, as badass as they are, and they are at the mercy of circulation. And so it takes too long for water to get through those systems. So you have to have something out there. And so bromine is an alternative sanitizer to chlorine. Now, because of its elemental structure, because it is below chlorine can actually oxidize it.
That's correct.
That is what changes the game here, because bromine cannot oxidize chlorine. It doesn't go the other way around. Chlorine in the water and pretty much any other oxidizer can actually regenerate or recharge bromide ions. So I want to take a step back from this, and Terry, I want you to elaborate on this. When chlorine is used up, you get chloride ions, which is a Cl-. They're inert. Tons of chlorides in our water. They just stay there. But that's not the case in a bromine pool. Why not?
No. Just kind of backing up to the chlorine first with the chloride ions, sodium chloride, which is basically the result of what's left behind from many forms of chlorine, particularly liquid in the pool. That cannot be oxidized back into an active disinfectant. It can be done through electrolysis, as we know, but you can't oxidize sodium chloride and make it an active disinfectant again. However, with bromide, which would be like sodium bromide in the pool or in the spa, when that is oxidized, you're creating active hypobromous acid and then hypobromate ion, but you're getting active bromine.
These are very similar. I want to do the parallels with you, Terry. So I'm going to say the chlorine, and I want you to give me the bromine equivalent. Okay, rapid fire. Hypochlorous acid is the active form of chlorine. In bromine, that is
hypobromous acid, which is HOBr.
Okay, and then if the pH goes too high in a non-stabilized pool, the hydrogen dissociates and you get the much weaker hypochlorite ion, which is OCl-. What is that in bromine?
That is the hypobromate ion, which is the -OBr.
Basically the same concept, people, if you're following along.
Very similar,
it's
yes.
The same basic idea here. It is also pH dependent, although the pKa value for that, like where they cross for chlorine is 7.5 pH, where they crisscross for bromine is actually 8.6 something. I think it's 8.65 pH, so it's much higher. But the point is it's still in equilibrium.
Yes.
Now, when chlorine gets reduced, you get chloride ions.
Correct.
When bromine gets reduced, you get
bromide ions.
The only way I can do anything with these chloride ions is to use electricity in a salt system. For example, use electrolysis. I recharge it and I create chlorine gas.
Split the molecule. Yeah.
Right. I create chlorine gas. How do you recharge bromine?
Through oxidation. Bromide is easily oxidized and can be oxidized over and over and over again.
And it gets oxidized into what?
Into active bromine. So initially hypobromous acid.
Not bromine gas, though.
No.
So that begs the question. Actually, I didn't find this in my research. Do you think if you ran bromide through a salt system that it would create bromine gas?
I don't believe so. I don't think it will.
If you're a chemist,
that's a good question.
Yeah, if you're a chemist at home,
that's a question. So that might be a Richard Falk question, or somebody in that level.
Yeah, maybe. I don't know. The point is they're very similar in terms of elemental structure, but because bromine is one tier below on the periodic table, it's a one-way street.
Yes.
Chlorine can oxidize it. So can hydrogen peroxide. So can AOP, or I should say hydroxyl radicals. So can ozone. They get oxidized into hypobromous acid. They then attack whatever, oxidants, bacteria, germs, whatever it is. What happens then?
It reverts back to the bromide after that.
Or byproducts.
Or byproducts, but one of those byproducts or primary byproducts is going to be back to the bromide.
So it's like chlorine, right? If chlorine oxidizes, it gets reduced to chloride. But if it oxidizes a nitrogen compound, because it combines with it, you actually get chloramines.
Right.
And in bromine, you get
bromamines.
Exactly.
Yeah. Okay. So I get where you were going with that. That's definitely a byproduct with any nitrogenous material that's in the pool. You're going to get that combination.
Now, people have said that bromamines are way worse than chloramines. I disagree with that from personal experience. Now, it depends on the swimmer. I guess some people think they're worse. I know there were definitely swimmers who had more issues with bromine than chlorine, and that was part of the reason my university switched. probably because of cost too. But for me, chloramines were far more rough to breathe in.
Yeah, any research I've done, and in fact, even early on from classes I took from Bob Lowry, he would always say that chloramines were more irritable and had, more effect than bromamines, that bromamines really weren't as irritable or as, here's another word for you, odoriferous. As the chloramines.
I should have you on the podcast more. We're just going to have Terry's vocab. It's going to be a whole segment.
But that's what I've been taught. So to hear you say, you've heard people say that the bromamines are much worse. Man, I don't know. That's not what I've been taught.
Well, it's a matter of opinion. See, I agree with Bob Lowry on this from personal experience. Bromamines were not nearly as harsh on me, but it really depends on who it is breathing. It's up to them if their body reacts a certain way. Now, the bromine cycle continues because now you have the bromides and you oxidize it with a chlorine shock, a non-chlorine shock like potassium monopersulfate, hydroxyl radicals, ozone, etc. And then, like you said, it comes back into hypobromous acid. I want you to explain to our listeners, Terry, why this regeneration cycle is cool, but more importantly, why it's a problem if you're using something like sodium bromide on a chlorine pool.
Yeah, so it's cool from the standpoint of once you put that in there, you're just going to add an oxidant. And as long as you have a residual of that bromide in the water, you're going to continue to create active disinfectant in that body of water. And that's a good thing, and that's a cool thing. I remember a long time ago, some guy, and I think it was actually a chemist or something, this goes back a long time ago, but he actually stated that he thought his ideal pool was going to be a pool where, we'll laugh at this now, but where he would have an ozonator on the pool and he would just load his pool up with sodium bromide because he could just have this active, the ozone would be actively, continually oxidizing the sodium bromide.
Well, in theory, he would have indefinite bromine, but as we're going to discuss in a moment, that is not a good idea.
Right. There's reasons today why that would not be the way to go. So that leads me to this one, to where there are maybe some unintended contribution of bromine or bromide ions into the pool. Maybe folks don't even know, but they're trying to treat their pool for algae, for example. They're using a particular type of algicide, and they know or they don't know that algicide is 80 to 99% sodium bromide. There are these sodium bromide algae killer products out there. And those get used, but it only takes a few ppm of sodium bromide to get into a pool, and that pool can be flipped to being a bromine pool. And the reason that will happen, obviously, is as we've been talking about, the cycle of bromine, to where you have bromide, you oxidize it with either chlorine or some type of an oxidizer, and it oxidizes into active bromine hypobromous acid and then hypobromide ion, and then reverts back to that inactive bromide. And that inactive bromide, as long as it's in the water, has the capability of continually being oxidized into an active bromine form over and over again. It's a cycle. Yeah. And so when you add chlorine, there's going to be that instant reaction of where chlorine's going to become the oxidizer rather than the sanitizer, and it's going to oxidize the bromide into active bromine.
Yes. Hold on. Pump the brakes there, because that's a deep concept that deserves a little bit of elaboration for our listeners. Why does chlorine go after bromide ion before, say, killing germs or metals or nitrogen compounds? Why would it prefer to oxidize bromide ion?
Well, so if you go back to the table of elements, that's one thing. It's more reactive to bromine. Bromine's in that same family. But, the thing about chlorine is when there is anything, any type of material or contaminant present in the water, the first thing that chlorine is going to want to do is oxidize. It's going to get consumed in oxidation. And bromine is something that it just has a very strong affinity to and reaction with very quickly.
That's what I heard too. And in the research, the word affinity is actually used in almost every source I found, in that it's a very low amount of energy it takes for chlorine to oxidize bromide ions as compared to something like, sunscreen. It takes a lot more chlorine to oxidize sunscreen, whereas it takes almost nothing for it to charge bromine. And so, as you said, if you use enough sodium bromide, which is just salt, by the way, if you put that in the pool, you now have bromide ions that are in there permanently, and chlorine's going to keep going after them and recharging that. And yeah, you'll get a little bit of sanitizing power out of that. Good for you. The problem is it keeps going back to bromide and keeps consuming your chlorine. The moment you have more parts per million of bromide ions in your water than you do free chlorine, that's the moment you have a bromine pool, and there's no turning back.
Yeah.
So what do you do? Let's say I'm a pool guy. I've used sodium bromide 3 or 4 times this season, and now I can't hold chlorine. I literally got this call last week, and it's only June, Terry. He can't get a free chlorine reading. He's got a green pool, and he's nuking it with chlorine, and he comes back the next day, and it's almost nothing.
Well, a lot of different things that can cause chlorine demand for sure. And that could be a whole nother podcast that we could discuss that. But if it's bromine, and if it's a result of levels of sodium bromide in the pool from using certain products, then really there's only one solution, and that is drain the pool.
Well, you could do reverse osmosis, I suppose.
Well, you could do reverse osmosis, sure. Draining is surely something that's pretty simple. But again, we're kind of in this world where certain areas are under drought restrictions, and draining is a problem.
And if you have a vinyl liner, you can't just drain it completely.
Or a fiberglass. Yeah. And I'm not sure really that you would need to drain completely necessarily. A quarter of a way to maybe halfway, and then you dilute out. That could be enough to where you knock down that sodium bromide to a level where it's not going to create the demand or the consumption on chlorine that you have, and then you could go from there. There's ways that people talk about that guys can determine whether or not they have a bromine pool, or then that they can do an ammonia bucket test and all that kind of stuff. And that's fine if you want to take the time to do that. But really, I think if you know that you've used anything that contains sodium bromide, if you're having the issue with the chlorine demand, I think the simplest thing is just to try to drain and dilute some of the water down and see if that makes a difference.
Right. Well, it's not just if you use sodium bromide. There are bromine products out there, like these spa tablets. I want to get into them for a second. If you use any of these products, you're going to have bromide ions. It's not just sodium bromide that puts bromide ions in here. There are 3 primary types, according to Bob Lowry, and you used to sell all of these in your retail store.
Yep.
So the first one, of course, we've already covered, which is sodium bromide, and then a different oxidizer. That's the main thing that we see in chlorine pools, at least. But then you have tablets. The first one is called BCDMH, which is bromochloro 5,5-dimethylhydantoin.
Methylhydantoin.
I mean, if you can't pronounce it, you probably shouldn't use it, right? So these are in tablets or sticks, and they have a relatively low pH, like 4.5 to 4.8. What's your experience with these tablets?
We sold them a lot for spa use. And there were a couple of reasons, and I know you've inferred to some of this in the blogs and so forth. One was that some people felt like bromine was milder. They didn't get the odor like they do from chlorine. You had some people who were allergic to chlorine, so they had really bad reactions to chlorine, so they were advised to switch to bromine. But I can tell you the main reason we sold bromine in hot tubs had to do with the fact that chlorine just didn't last in higher temperatures of water. So chlorine is going to dissipate pretty rapidly once you get above 80 degrees because it tends to gas off faster, where bromine will hold to about 100 degrees before it will start to dissipate quicker or gas off quicker. So that was the biggest selling point of bromine for hot tubs that we had when I sold it.
That makes sense. It's always market driven, right? It's always market driven, whether it's the best solution or not.
So it was that better in hot water. You didn't have to use as much. It lasted longer, and you knew you had disinfection even if you heated your spa to 104 degrees.
Well, what I find interesting is this tablet, this BCDMH, contains chlorine, and it creates HOCl and it creates HOBr, and then you still would need to use a separate oxidizer to recharge it. So you use it kind of like trichlor tabs. Is that correct?
Yeah, the real reason the BCDMH with the chloro in there is obviously the chloro's in there to create the hypochlorous acid. And we talked about the periodic table. Again, it's above bromine, so it's more reactive. So what's it going to do? It's going to oxidize the bromide in there and create active bromine. So that's kind of the technology of those tablets. So the interesting thing there is we were selling those BCDMH tablets, and we'd have the certain persons who would come in and say, I'm allergic to chlorine. And so somebody told me I need to switch to bromine. So we would sell them the tablets, and they'd come back and go, well, I'm still, my skin's breaking out, or whatever the issue was, the allergy from the chlorine. So then we came to realize, oops, there's chlorine in these tablets. So that's not solving the problem.
No, it's not. But there is another tablet out there, and this is called DBDMH, a lot of acronyms here,
Right.
which is dibromo-5,5-dimethylhydantoin.
Yeah.
Yeah, so this one contains 0 chlorine. This is pure bromine, and it's got a relatively neutral pH of about 6.6 to 7. What would this be used for?
Same thing, spa use, or I suppose pool use as well. The difference here, obviously, is just that rather than chlorine acting as an oxidizer, I think it's that you have 2 bromine rather than 1. So you're able to get some oxidation from that.
Many years ago, I was up in Michigan, and until I was doing the research on this, I didn't even think about it. But they actually had a giant tank of bromine, and it was liquid bromine. And they were feeding liquid bromine into a pool. And get this, Terry, it was an outdoor pool.
Wow.
I didn't know anything at the time. I didn't think anything of it. We were putting PR 10,000 in the pool. It was clouding up like crazy, but I had no idea that that wasn't supposed to be done. I was like, oh, cool, bromine, because I swam in it in college. I didn't know what I didn't know. And now I'm thinking, oh, there's no way that should be on an outdoor pool at all.
No.
So liquid bromine is not really common, I've come to learn.
No.
But they definitely had it. It was a huge tank. I mean, it was probably 8 feet tall by 3 foot diameter. Massive tank of it.
I know that there are forms of sodium bromide that are liquefied.
Maybe that's what they had then.
It could be that. I really can't see how they could have gotten away regulatory-wise with having pure liquid bromine.
I don't know, but it was definitely a liquid.
It could have been liquid sodium bromide, perhaps.
So I want to pivot here to keep the conversation moving, just because there's so much to cover here. I feel like we could do a 3-part series on bromine, but I don't think there's enough people that use it that really need a 3-part series. I want to talk about the byproducts. We touched on bromamines when bromine oxidizes nitrogen compounds, similar to chloramines. But there's another type of byproduct here called trihalomethane. A trihalomethane is a carbon and a hydrogen with 3 halogens on it.
Yes.
Well, the only 2 halogens you're going to have in a pool, potentially, or a spa, is going to be chlorine or bromine, or both.
That's correct.
So there are 4 variations. There are 3 chlorines or chlorides on this thing, and that's called trichloromethane, aka chloroform. You've probably heard of this. It's what you put on a rag in the movies to knock somebody out. So that actually gets created in chlorine pools pretty frequently. That is 3 chlorides on a methane. If you have 2 chlorides and 1 bromine on a methane, you get something called bromodichloromethane.
Mm-hmm.
If you have 2 bromines and only 1 chloride, you get dibromochloromethane. They're very creative with their names, Terry.
Yes.
And then, of course, 3 bromines is tribromomethane. So there's 4 types. And if you use these bromine products in a chlorine pool of any kind, or you use DCDM, whatever the one that has chlorine in it is. I'm too lazy to scroll up and look at the complex name.
BCDMH.
Thank you, Terry. You could have all 4 of these. Now, these things are nothing to screw around with. These are not good. You do not want to breathe these things in, and you can have them all in a bromine pool. Right. What are your thoughts on trihalomethanes?
Don't want them around. They're just harmful to anybody. There's a lot of reports of people that use bromine spas, and they actually get a sort of lung problem, which is a bromo-enhanced lung problem that can occur. And there's skin problems, all sorts of problems from these trihalomethanes of bromine, and so you don't want them.
If you Google THMs in water, you will see an abundance of research. They're a big problem in drinking water as well. It's really the drinking water industry that I did a lot of my research in, because there's just not a lot, other than Bob Lowry and a few other sources, there's really not a lot of information available on bromine in the pool business because it's used so rarely.
Right.
So when I was researching for all this, most of what I was reading was CDC, EPA, NIH, and then peer-reviewed journals, and they were talking about it in drinking water. None of these byproducts, bromamines, trihalomethanes, none of them compare to the Mac Daddy of them all. And this is the real problem with bromine that I believe is the real reason it should not be used ever in an outdoor pool or a pool with a secondary system on it. Terry, what do we want to avoid in bromine pools?
Well, there's another, isotope or species of bromine that can be created when you go through all this, particularly with UV and ozone and those types of things. And that is what we call bromates. And bromates have been proven more recently to be carcinogenic. What we found in pools and hot tubs is when you oxidize, particularly with ozone or some of these very powerful hydroxyl radicals, you can create a percentage, which I think that percentage could be like about 23% something.
That's correct.
Of bromates. The EPA information that is out there that's available, primarily they don't want it in pools with UV at all, or in outdoor pools, period. Outdoor pools, because of the UV sunlight. They primarily are looking at ingestion of the water. And so the theory or the thought is when someone swims or when somebody's active in a pool, they're going to swallow some water. It just happens unconsciously. And if you're swallowing that with bromates, then that's a carcinogenic risk.
Absolutely. And it's not just UV. It's ozone. As you said, it's hydroxyl radicals.
Correct.
Basically, unless you're shocking with chlorine and potassium monopersulfate, those are the only two oxidizers that I found. Now, I could be wrong about this, but those are the only two common products that I've found that might be used in a pool that do not create bromates. But the moment you make that an outdoor pool or spa that gets direct sunlight, you could still have them. You absolutely do not use bromine.
Yeah. As far as the EPA goes, they just don't have the data enough yet. I mean, it's being researched and so forth, but they haven't got the data yet to really state that if somebody's sitting in a hot tub and it's just absorption, so they're not swallowing water, and hopefully people don't swallow hot tub water too much. They just don't have the proof that it's through absorption that you can get this. But as you know, you looked at the EPA paper, the EPA has gone as far as to say that they recommend that if that hot tub is outdoors and you're using bromine, that when that hot tub is not in use, it must be covered at all times to prevent the sunlight.
And they also said in this interim decision that you sent me that any of these products should remove outdoor swimming pool use on their label so that you don't encourage outdoor use, outdoor pools and spas. So they're aware of the sunlight thing, and I think it's just a matter of time before we get more clarity on that. From our perspective at Orenda, our philosophy, again, proactive pool care, no chemical conflicts, and no long-term byproducts left behind. Right there, you're violating two of those three. As such, I cannot recommend bromine use on anything outdoors or anything exposed to these oxidizers. Again, if you're going to use bromine, it would only be indoors, and you would be using either chlorine to oxidize it or potassium monopersulfate. And I feel bad about this because in theory, it sounds great. Oh, I'll put an ozone or an AOP on and I'll have infinite bromine. But bromates kind of ruin that. And you can't really get rid of them. They're kind of like nitrates. You have to drain them out. You have to RO them out. And they're harmful. There's no doubt abundance of research on how harmful they are. I cite a lot of them in the blog. Read it if you want to know, or just avoid bromine and don't worry about it. But one of the big questions we get, Terry, is bromine compatible with chlorine? And it's kind of a nuanced answer because, like we said, in that one tablet, you have both chlorine and bromine in it.
Correct.
And I think it's yes and no. Yes, in that you can use chlorine to shock bromine in a bromine pool. You can recharge bromide ions safely into HOBr and continue that cycle. That's fine. But no, you cannot use bromine products in a chlorine pool, or at least you should not. And if you do not do it very often because sodium bromide, like we said earlier, can convert your pool into a bromine pool, and it can do it surprisingly fast.
Yeah, the thing about it is if somebody thinks, well, okay, if they're compatible or whatever, and so what, I have a bromine pool. Well, I mean, I think, as you know, there's no stabilizer for bromine. So you can't run a bromine pool in an outdoor pool where there's going to be any amount of sunlight. And in fact, it's like I think 60% of your active bromine is going to be dissipated by the UV sunlight within 2 hours. Within 4 hours, you're going to have nothing. And so that's the big problem that, you're creating active bromine. Okay, good. That's a disinfectant. Yeah, but it's going to immediately get burned out by the sunlight. And now you've got nothing, zero. So you can't really have some chlorine, some bromine type of pool. That's really not a possibility.
There are some PCTI tech bulletins. PCTI, of course, is Bob Lowry's Pool Chemistry Training Institute, which you, Terry, have been teaching ever since Bob's passing. There is a tech bulletin on this. We link to it in our blog. I think we're going to be talking a little bit more about this in some classes this upcoming season because we do get a lot of questions about it. That's why we wanted to get this podcast out there. If you have questions about bromine, or maybe you have been using sodium bromide and you want to talk to us about it, we don't judge you because nobody knows what they don't know. Feel free to reach out to us. You can email me directly, podcast@orendatech.com. You can also email Terry if you want to talk to him instead of me. Terry, isn't it Ask Terry at Hassa or something like that?
Ask Terry at HassaPool.com.
So you can email Terry, and you can also check out our help center. I don't want to hold myself to a timeline, but I'm going to try to update it with some bromine questions in there. But that is ask.orendatech.com. Terry, is there anything else you want to add to this? Because I think we covered it pretty thoroughly.
Only just to say that there's a lot more data that's going to come to light on this. Keep in mind that the EPA, if they're going to do anything, they're going to do it because it's based on data. And where the EPA stands right now, in particular with bromine in the hot tubs, is just strictly because they didn't feel like they had enough of the data to make some really hard rulings there. But I will tell you that the data is coming. Once the EPA has that, I think that in the future we're going to see some pretty hard rulings on bromine. So that's something maybe to be aware of and to put in your back pocket for now. But yeah.
Well, I appreciate you being on here. Thank you for being the expert. You know a lot more than I do about it, and thanks for helping me with my research. I don't know what we're going to talk about in the next episode, but thank you for sticking with us. Thank you for continuing to listen to this podcast. We do this podcast for you, so thank you. If you find it valuable, share it with your friends, and have a wonderful season. Terry, thanks again for being on the show.
Thanks, Eric.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.